So Riemann sums. When you see the word Riemann, what do you think? I'm joking. Why? I was like, what previous experience do you have? Okay. Maybe there's something I don't know. Okay, so guys, in calculus, when you see the word Riemann, you immediately think rectangle. Okay? Riemann is a person. Okay? Riemann is a person, a mathematician. But when we see the word Riemann, you think rectangle. And how do we find the area of a rectangle? Length times width, base times height, whatever your preference is. Okay? So guys, when they ask you to do a Riemann sum, and this is typically in a free response question, okay, occasionally in multiple choice. So it's usually contextual, just like this. Riemann sum, you think rectangle, area equals base times height. And guys, they want to see that you are summing up areas of rectangles. Okay, they're going to look for products and a sum. So if you're really good at mental math and you were to write, this is 90 plus whatever this is plus, you would not get credit because we wouldn't see any products. Okay, we have to see a product and a sum. Also, if there's 4 rectangles, that means I should see 8 numbers, right? Base times height plus base times height plus base times height plus base times height. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to say 8 numbers. And typically this is graded on a 7 out of 8's rule. If you have at least 7 of these 8 numbers correct, you can get the first point, even if you made a minor error. Does that make sense? Also, did y'all talk about, hey, I don't want to go any further than this right here if I don't have to? Okay, because why would we not want to go further? That is a nice left side, good. So this is our answer, unsimplified. If I were to simplify on a free response question, A, I'm wasting time. Also, I might make a mistake, right? No, but that's good. I'm glad you said left side, okay? That's one of the things. Sometimes I notice occasionally a student confuses left and right. And I really thought it was because they, confuse left and right hand. But then when I sit down and talk to them, when you draw these rectangles, don't pay attention to the direction that you're drawing. It even happened today. We did this, started this yesterday, and I was watching a student today say, she drew this rectangle, and she was like, all right, this is a right rectangle. And I was like, wait. Don't pay attention to the direction you're drawing. Put your finger on the vertex of the rectangle that's touching the curve. Is that the right side or the left side? Left side. So that's a left rectangle. Okay. So y'all did left, right, midpoint, and trapezoids. Good? Okay. Neat. All right, so y'all started drawing these yesterday, is that right? Okay. So given this function, negative x squared plus 9, estimate the area bounded by the graph. And later on, we'll find the exact area using calculus. All right, so left Riemann sum. When we see the word Riemann, what do we think? Rectangle. How do you find the area of a rectangle? Base times height, length times width, whatever your preference is. All right, so guys, so think about these rectangles. Let me just highlight this one in particular. So when we do that rectangle, the base of the rectangle is not an actual x coordinate. It's going to be some delta x. Yes? Okay, because that's another common mistake. Kids like to just record one of these x coordinates as the base of the rectangle. The base will be some delta x, okay, the width of that subinterval. And then the height will be an actual y coordinate, an actual function value. Okay? All right, so we set this one up. I want to use function notation here, so I'm going to call this f of x negative x squared plus 9. All right, so we got 4 rectangles that you've drawn here. So we got our first rectangle on the interval 0 to 1/2, our second rectangle on the interval 1/2 to 1, and so on. All right, so we start summing up areas of rectangles. So what's the base of our first rectangle? 1/2. And then so here's my subinterval, 0 to 1/2. Which value is on the left? 0, so my height is going to be the function value that corresponds to the x value on the left. So this would be f of 0. And we'll do the arithmetic on the next step. So plus. All right, moving to our second subinterval. Okay, so on the interval 1/2 to 1. The base of the rectangle is some delta x, which again, 1 minus 1/2 is 1/2. So on this interval, which value is on the left? 1/2. So the height is the function value that corresponds to x equals 1/2. All right, so our third rectangle on the interval, 1 to 3/2. What's the base? 1/2. And what's the height? Okay, so I'm right here. I want the y coordinate that corresponds to the x value on the left side. So f of 1 plus, and I have one more rectangle. What's the base? 1/2. And what would be our height? Good, f of 3/2. All right, so let's do some arithmetic now. 1/2. All right, f of 0. What is the value of f of 0? 9 plus 1/2. All right, f of 1/2. Nice. Wait, is it 37? Are we subtracting? So 9 would be 36/4, right? You were close. I was watching your fingers move so quickly. So f of 1/2, it's going to be the opposite of 1/2 squared plus 9. So 1/2 squared is 1/4. So the opposite of that is negative 1/4 plus 36/4. Good? I'm just glad you gave me the answer as a fraction. All right, moving on. What is f of 1? 8. Everybody happy with that? Plus, and f of 3/2. 27/4? That's what I was thinking. All right, do we want to go further than this? No? Why not? We got our 8 numbers. Could I have stopped right here? No. You can't leave your answer in function notation. I would have to make those substitutions, either pull those numbers from a table or plug them into the function like we did. But I would definitely stop right there. If this were a contextual problem, I'd make sure to include the units. But I would definitely not do the arithmetic unless I have to for a multiple choice question. Oh, now we're doing 6 intervals, huh? But you've already got it partitioned into your 6 subintervals. Did y'all draw these? Nice. All right, so, and of course, to find, if they tell you 6 equal subintervals, I can just take the width of the entire interval, 0 to 2. So there's your b minus a divided by n. So the width or base of every rectangle, if they are equal subintervals. B minus a, when I say b minus a, there's your a, there's your b, divided by number of intervals, and that's how you can find that common width. All right, so 6 rectangles. Now, because these are equal subintervals, I know the width of every rectangle, my delta x for every rectangle is the same. Are you okay if I factor that out? So could I have written this one as 1/2 times the sum of 9 plus 35/4 plus 8 plus 27/4? Is that legal? It would if it's equal subintervals, but from a table, it rarely is. Yes, that would count. All right, is everybody okay with that? Only because it's only legal. This only works because we have a common base, common width. All right, so 1/3, is that right? Okay, so on this interval, 0 to 1/3, which one's on the right? 1/3. So the height of this first rectangle would be the y coordinate that corresponds with x equals 1/3. So f of 1/3 appears yes, because this is a, yeah. All right, so my next subinterval on the interval 1/3 to 2/3. So remember, the base of every rectangle is that delta x. It's not an actual x coordinate. Okay, we have that common base of 1/3. All right, so what's the height? Which one's on the left? Oh, sorry, the right. 2/3. So the height of that second rectangle would be the y coordinate that corresponds with x equals 2/3. So f of 2/3. How many heights will I need? 6. Good. So what's the next one? 1 plus f of 4/3 plus f of 5/3 plus f of 2. Okay, are you okay if we skip the arithmetic part of it? Okay, do you want to do these two? I think our time would be better spent looking at some contextual type problems. Good? Yay? Okay, but do you understand the difference between left, right, midpoint? Okay, so those are all Riemann sums, so you'll either be asked to do a left Riemann sum, right Riemann sum, midpoint Riemann sum, or trapezoids. Okay, trapezoid. When you're accumulating area with trapezoids, we don't refer to that as a Riemann sum. Oh yeah. So you won't see that because Riemann, when you see that word Riemann, you just need to make that connection to rectangle. And remember, area of a rectangle, base times height. Do you want to show it? There was one year where the base was 1, and it was 1 times 8. And the kids that didn't write the 1 had the potential to lose a point if they missed another number. So even if it's 1 times something, don't do that arithmetic in your head. Okay, so we're going to move on. All right. So this is called a database question because we're presented with just some snapshots of data. And typically, you'll always have a database question on the AP exam as free response. And it is typically a contextual type problem. Okay, so this is our database story question. So we have water flowing into a tank over a 12-hour period. The rate at which water flowing in, we have 1, 2, 3, 4 snapshots. So R of T, okay, given in this table, measured in gallons per hour, and they tell us that 150 gallons of water in the tank at time 0. All right, first question. Left Riemann sum. 3 subintervals. Are you okay with that word subinterval? Yeah? Okay.
Can you tell me? So you're not okay with the word. Just say you're not okay with it.
He's got it.
So you take the interval that you have and you divide it into other. So given the interval 0 to 12, then you divide that into other intervals.
Okay, so we want to use the left Riemann sum, 3 subintervals, to estimate the area under R of T from 0 to 12. Okay, now, remember you're going to be taking a time test. Okay, so you might be tempted to draw a graph here, because I see a lot of really pretty graphs, and they shade, it's really nice, but okay, we don't want to waste time. But here's what I might do. I might say, okay, if I were to graph this, what would be graphed on the x-axis? Okay, 0 to 12, which is time, and hours. So T in hours. And what do we have on our y-axis? Those R of T values, right? Rate, which is in gallons per hour. And I don't know what this graph looks like. I don't care. Okay? Don't really care what that graph looks like, but I would show myself, okay, so if I were to draw a rectangle, the base of that rectangle would be what? Some delta T. So it wouldn't be an actual time value, but some delta, because we're accumulating change that's happening over time. So it's something that's happening over an interval of time. And what would be our height of each rectangle. Some R of t value. Okay, so the base, delta t, height, R of t. All right, so it says use left Riemann sum. All right, so this is how I work myself through these problems, using 3 subintervals indicated by the table. So here's my first subinterval. So there's my illustration of my first rectangle. What's the base of this rectangle? 5? 5 what? 5 hours. And what would I use for the height? So on this interval, which one's on the left? Okay, there you go. Time equals 0. So I use that function value, that R of t value that corresponds with time equals 0. So let's say, all right, 5 hours times, we're doing area, so it's multiplication, the delta t times the corresponding R value. As long as they're not going to look here at every unit, so as long as your answer, ultimately your final number, has correct units, you're good. So my next interval, my next subinterval, from 5 to 8, what would be the base of that rectangle? What's the delta t? 3. And what would we use for the height of that rectangle? 8.8, because that's the R value on the left side. So 3 hours times 8.8 gallons per hour. All right, and then our third subinterval on the interval 8 to 12, what would be the base? 4. And what would we use for the height? Plus 4 hours, 9.3. All right, so notice we didn't have equal width subintervals, and that's very common from a table. So that's okay. So I couldn't factor out a common height there. So I got 1, 2, 3, 4, 5, 6 numbers. So let's say I accidentally recorded 9.2 here. Well, my answer's wrong, but I would still get a Riemann sum point because I showed enough evidence that I knew what a Riemann sum is. That's why we want to show base times height plus base times height plus base times height. We have to see a product. We have to see a sum. We have to see a sum of products. All right. Has anybody done the arithmetic? Now, typically, you wouldn't be expected to do this in your head. Okay, and notice hours divides out, leaving us with summing up gallons. So 103.6 gallons. All right, what does that number mean? What does it mean contextually? Work on that just a little bit. No, work on that a little bit. No. Gallons. Is that true though? Do y'all agree with that? Very nice. That's good. It's getting a workout. Think about the problem. Read the problem again. There you go. Okay, so work on that. Start over. What does it mean? What does this number mean? Okay, good job. Okay, so this number right here is just the accumulation of change. Okay, no, it's because there was already water in the tank. So this happened in my class too. They said, all right, there it is. There's 103.6 gallons of water in the tank at 12 hours. No, there was already 150 there. Okay, so this right here. So back to derivatives. Remember when we talk about derivatives, I say, what is a derivative graphically? Slope at a point, right? What is it contextually? Instantaneous rate of change. So similar, we're working towards building up to what an integral is in calculus. So I would always ask, what is an integral graphically? What's related to area, right? We're using area to estimate what we call integrals. And then what is it contextually? It's the accumulation of change. So this does not provide us with a snapshot of how much water is in the tank. It provides us with the accumulated amount that was added to the tank because we have water flowing in. Does that make sense? So let's see. This is of water added, or that flowed in, that entered. Is that how you would say it? So make sure when you read it that you have indicated that it's something that's happening over an interval of time. So if I were to say this is the amount of water that's added to the tank at time 12, at is like an instant. Okay, so that one word would cost you the interpretation point. So make sure it's over an interval. Also, be specific about the time interval. I can't just say over 12 hours. I have to be specific about which 12 hours. Okay, does that make sense? From t equals 0 to t equals 12. Typically when I interpret an integral, the limits will be clearly laid out. I name the limits from t equals this to t equals this. So there's no debate about it. Okay, so what if I asked you, so at time 12, approximately how much water is in this tank? There you go. So now we have to consider the initial. So it's an initial, how much was already there at time 0, and then take into account how much was added to the tank during that 12-hour time interval, and sum them up. Good? All right, so you guys at your table, do this one. If you don't want to include the units like within the calculation itself, just make sure at the end your units are correct. Yeah, like maybe even like at the graph, since this is gallons per hour times hours, this area itself would be gallons. Do you have the homework assignment like displayed? So maybe we can do one together. Did you say we have to do math? It's still an approximation for the same thing. Is it a 4? Shouldn't it be a 5?
No, he's doing it backwards.
Oh, you're doing it backwards? Huh?
No, you're doing it right. You got the right.
I mean, it's not going to cost you points.
Oh, I actually.
What did you get? 108.7? 108.7? Just kidding. I'm so sorry. Sorry. If you're watching this later.
So my question is, we could have stopped here mathematically, right?
Correct.
But if you did and you had all this in here, what do you?
It would have been fine.
And then you explain that it's just gallons down here.
Yeah, if the follow-up question is, what's the interpretation? Yeah. I'm writing it different, and the reason why I'm writing it different is for the purpose of a multiple choice question. On a multiple choice question, they typically look at sentence stems that teachers teach and try to change it up to make sure you actually understand it versus just memorize something. It's not to try to trick you, it's to make sure you really understand. So another way to interpret this number. So another way to interpret that number, approximately 108.7 gallons of water are added to the tank from t equals 0 to t equals 12. No. I can tell you, wait, what?
Oh, you're asking about
Of what month? That's too late. That's too late.
No, actually, after y'all left,
It should be somewhere between April 4th and April 7th. Okay, I was going to say I can give you the window. Okay, any questions on this? You good, Cameron? Which math did you do wrong? So another reason why we stopped. Does it make sense? So, yeah. So stop right there because trying to do the arithmetic probably took you a lot of time and you talked yourself out of a point. You had both points, but then you talked yourself out of 1 point. Were you raising your hand? Oh. Okay, are you good? You good?
Just say this is the amount, and you don't have that. Well, is that they were taking forever to do their arithmetic.
Cameron did the same thing and he messed up. It's good. It's a good lesson learned, yeah. Okay. The practice. Did y'all all get one? All right, is everybody ready to move on and look at a couple of these questions from the homework? Okay, so we have a similar situation here, except we got oil, and it's leaking out of a tank. So the rate of flow is measured every 2 hours, data listed in the table. So what do they give us? 1, 2, 3, 4, 5, 7 snapshots of the rate. All right, so estimate the number of gallons of oil that have leaked out during the 12 hours by finding a left Riemann sum. What does the word Riemann make you think?
Rectangle.
Rectangle. How do you find the area of a rectangle?
Length times width.
Perfect. Now it says 3 equal subintervals. So what's going to be the width of each subinterval? Okay, why? So B minus A, to find the width, and this only works if it's saying equal. Okay? If it just says using the data in the table, okay, they might be unequal subintervals, but we could do B minus A divided by N. So in this case, B minus A, 12 minus 0, they told us a 12-hour period, and we want to use 3 rectangles, so the width, or length, or base, whatever you want to call it, 4. So that means my first subinterval, good, 0 to 4. So base of that rectangle would be 4 hours. Okay, so remember, if you need a little visual, just set up your axes and label. This would be hours. This would be gallons per hour. A rectangle, the base would be some delta T, and the height would be some rate value. And then gallons per hour times hours will yield gallons. So my first rectangle, 4 hours. What would we use as our height? Okay, why? It's on the left. 40. Plus, all right, my next interval would be from 4 to 8. So again, common base, 4 hours. What would be the height? 6. All right, and my third rectangle on the interval. Again, so again, base, 4 hours. Height, 26. Do I want to go any further than that? All right, so guys, if we were going to do part B, what would we use as our heights? There you go. And then for midpoint, what are we going to use as our height? Okay, because I want to move on to another problem. So midpoint, it's the same subintervals, right? So 0 to 4, what's halfway between 0 and 4? 2. And what's the height, what's the rate that corresponds with time 2? Okay, so everybody okay? Use the one on the left when we're doing left rectangles. Use the one on the right with right rectangles. Midpoint would be in the middle. This one doesn't ask about trapezoids. Okay. Now, look at the wording of this question. So estimate the number of gallons that have leaked out of the tank during the 12-hour period. So during, this is something that happens over an interval of time. So it's asking you for the accumulation of change. So if we were to calculate this value, what would it represent? The approximate amount of oil that leaked out of this tank on the time t equals 0 to t equals 12. Go to number 5. Similar situation, but now we have oil being pumped into a tank. We have 5 snapshots of the rate at various times between 0 and 12. All right, so look at the wording of this question. Do you see the difference? All right, so now it says estimate the number of gallons of oil in the tank at. So we're looking for, if I took a picture at time 12, approximately how much oil would be in this tank. So now what do we have to consider?
One rectangle.
Okay, so guys, if I want to know, if I want an actual amount of oil in this tank, I need to consider what was already there and how much was removed, right? So this would be initial plus change. And guys, this is tricky, okay? And after my kids, occasionally, when I meet my kids in the cafeteria after their AP test, I hear them fighting about the initial value. And some kids are like, oh, I forgot the initial value. What? We needed the initial value? So sometimes it's hard. Do I need the initial value? Is it important in this question, or do I not? Okay, so if it's asking, so the wording of this question. So this is an accumulation of change, right? I'm accumulating what's happening over a period of time. So it just wanted to know how much change took place during this time interval. Versus this one, how much oil is in the tank at this instant. So in that case, I need to consider, all right, how much was already there? And how much did we remove? And then in Unit 8, we start looking at problems that involve a rate in and a rate out. So you won't just have oil being pumped into a tank, it'll also be leaking out at a different rate. So then if they ask you how much oil is in the tank, you have to consider how much did it start with, how much was added, and how much was removed. Does that make sense? Mm-hmm. Okay, so it does say that, it's pumped into. Okay. So guys, to find the amount at time 12, I need to consider the initial amount plus the amount that was added. So initial plus change. All right, so how much did this tank start with? Good, 120 gallons. And then we're going to add the change that takes place. But because we only have 5 snapshots, the best we can do is approximate. All right, so 4 subintervals using the values from the table. So our first subinterval will be from t equals 0 to t equals 3. Remember, if we set up our axes, we have time, rate, rectangle. The base would be some delta t. The height would be some actual rate value. So what's the base of our first rectangle? 3. What would be the height? Because we are using left. What would be the base of our second rectangle? Good, because we're doing the delta t, 5 minus 3. And what would be our height? 6.8, because it's on the left. Our third rectangle will have a base of 4. And what's our height? And then my fourth rectangle on the interval 9 to 12, base of 3 and 5.9. Yep. But make sure you read the question carefully. Make sure, interpret whether it's asking you for a change or whether it's asking you for an actual amount. Okay, so at time 12, I have to consider that initial. So the initial plus change. Everybody okay with that? So just take a glance at number 6. Do I need to consider the initial amount on this question? Why? At. Now, think about the context here, guys. 113 degrees. The rate at which temperature is dropping. Okay? So you have to understand, because they use the word dropping, they don't write these rates as negative, but the temperature is decreasing, so the rates are negative. So when you get this accumulation, you're going to subtract it from the 113. Does that make sense? Because the change that takes place would be negative. Right? Our temperature of the coffee would be decreasing as the coffee cools down. So we're looking for an actual temperature, so initial plus change. If it just said estimate the change in temperature, we would not need to consider that initial amount. Okay? And guys, I will tell you, if you have a free response question and they give you an initial amount and you never use it, you made a mistake. Doesn't mean you need it for every question, okay? But you will use it at some point. In a free response question, they don't give you anything, any kind of distractor information.